Hi guys, in this video we are going to be talking about box plots. So you may have heard a box plot also referred to as a box and whisker plot. It is the same thing. Let's kind of break down where it gets its name. So the first part is kind of obvious. The box plot part comes from this rectangle right here that is considered our box. And then the whiskers are your two pieces on the end. So it's kind of like the whiskers of a cat or a bunny, any animal that has whiskers that's coming out the sides. What these box plots or box and whisker plots tell us is 5 different pieces of information based on that data set. The whiskers tell us both our minimum and then our maximum values. Then the box itself, the left side of the box gives us the lower quartile. Right side of the box is our upper quartile. And then the center line in our box is our median. And remember that median is the middle number of a given data set. We can use box and whisker plots like we can any other graph, a dot plot, a line graph, a bar graph, a circle graph, to help us represent data, and then we can answer questions based on that given data. So let's go ahead and try that out here. Miss Pearson or Mr. Pearson drives a bus for the city of Greenwood. Last month, he kept track of the number of bus riders each day. What was the least number of bus riders? One of the key parts of any type of problem like this, whenever you're interpreting, so saying what a graph means, what a graph is representing, is to really read and maybe even reread that question, because it helps you know what you're trying to find, which will allow you to focus in on that specific part of your graph. We are being asked in this case to identify the least number of bus riders. So the least number of bus riders would be our minimum amount. Well, our minimum amount is that left-hand whisker right here. So if we kind of look down to the data set, it would be this line right here. Now, that line, though, doesn't have any number with it. So what does that represent? Well, I can see that my graph goes from 60 to 70 to 80. So it's counting by tens, but I'm skipping a line. So if there's a line halfway, what is it really counting by? It's counting by fives, meaning this would really be 55, this would be 65, 75, and so on. Therefore, the least amount of bus riders, our minimum amount, is 65 riders. The principal of Oceanside Middle School recorded the number of students in each class. What was the upper quartile of class sizes? So let's read that question again. We want to know what the upper quartile is. So if you need to, if you don't have what each line in the box plot means memorized yet, that's okay. Look back at your notes. If you didn't take notes, pause this video, back it up, and take notes or grab a screenshot. But remember, this represents our minimum. We have our first quartile or the lower quartile, the median, the upper quartile, and then our maximum. So we're being asked for that upper quartile, which would be right here. And I can see that aligns with the number 26. So the upper quartile of class sizes is 26 students. Mitchell is on his high school's track team. He recorded his times in the 100-yard dash at each track meet last year. What was Mitchell's median time in the 100-yard dash? All right, we're being asked for median time. Remember, if I was just given a data set, I would have to calculate the median time, but our box plot tells us that is that center line in our box. That lines up with the number 22. Therefore, the median time for that 100-yard dash is 22 seconds. Last year, Winston tracked the amount of money he spent on groceries each week. The box plot shows the results. What is the range of the amount of money Winston spent each week? We're being asked to find range. Is that something that our graph automatically tells us? No, but we can figure it out. Because remember, range is the highest minus the lowest data point. And we have that information on our whiskers. If we look, we can see this is our minimum. This is the lowest data point at 40. And then on our other end, this is the maximum. This would be our highest data point. The range is when you take your highest data point, subtract the lowest. And 80 minus 40 just so happens to be 40. Therefore, the range of the amount of money Winston spent each week is $40. All right, when you start getting to the higher levels of this IXL assignment, you may have to do a problem like this, where you are supposed to select a box plot. So we're bumping up the challenge here a little bit. Stacy participated in a summer reading challenge at her local library. She kept track of how long she read each day. So we're given the data set, and we need to figure out which one of these two box plots matches it. What I'm going to do is I prefer to look at the minimum and maximum first, see if that will help me select my answer. And then if it does, great. If not, then we can move on to calculating the median or one of our quartiles. Let's clear this. So if we look at our data set, I see here that my lowest number, my minimum would be 0. And then it looks like my maximum is 60. So on the first graph, it is showing that. And then it's also showing that on the second graph. Okay, so I can't narrow it down. So next, let's find that median. Remember, your median is the middle number once your data set is put in order from least to greatest. So grab that paper so you can jot these numbers down. Once again, I'm going to clear this so we can have a clean, fresh slate. We put them in order. We start with 0, and then we have another 0. Next looks to be 10. 10 again. 15. 15 again. We have 2 20s. A 25. 35. 45. 50. And 60. When it comes to finding that middle number, after I write them down in order from least to greatest, I like to cross them off on each end as I work my way towards that middle. So we're just going to keep crossing one off from each side. And up, looky there, we got our middle. So our median is 20. Do either one of these graphs show us a median of 20? Yeah, the first one does. The first one has a median of 20, but the second one, it looks like my graph is counting by tens, has a median of 30. So that right there tells us the first graph, or the first box plot here, matches our data set. That is our winner. All right, we're going to do 2 more problems together. Nolan reports the weather for TVs 12, TZ12's popular afternoon news show. Last month, he tracked the noon temperature each day in the two largest cities in the area, Hooverville and Decent City. These box plots show the results. Which city had the lower median temperature? So we're being asked to compare these two and decide which one has the lower median temp. In order for us to compare, we first need to find the median for each one. For Hooverville, which is in green, I can see my median is right here. Now, once again, I got to figure out how my graph is counting since they just labeled every other one. I'm going 30, 34, 38. So I'm counting by fours, but skipping a line. So what are we really counting by? We're counting by twos. So 26, 28, 32, 34, 36, 38, 40, 42, 44. All right, so that tells me that Hooverville, I'll circle that in green so it matches, has a median of 36. And then Decent City, that median, remember, is that middle line or that centered line in the box, lines up right here with 38. And our question wanted to know which city had the lower temperature. Oops, I made a mistake when I wrote that. 38 for Decent City. I circled it, I just wrote it wrong. Well, 36 is lower than 38. Therefore, Hooverville is our winner. Hooverville has the lower median temperature. All right, last question. The Snowy Slope Ski Resort kept track of the amount of snow that fell each weekend during their busy season. This box plot shows the results. What fraction of the time did Snowy Slopes get 12 inches of snow or less? Well, this question's a little different. We want to know what fraction of the time they got 12 inches of snow or less. So right here is our 12 inches of snow, and it's 12 inches of snow or less. So it's going to go this way. When we look at our box plot, it is broken up into 4 sections. We have from our minimum to our low quartile, that's considered one section. Then our lower quartile to our medium is another section. The median to the upper quartile is another section. And then the upper quartile to the maximum is your last section. So we are split up into 4 different pieces. If we are wanting to know what fraction of the time they got 12 inches of snow or less, well, 12 inches is right here, meaning 12 inches or less makes up this portion and this portion. So 2 of the 4 sections are showing 12 inches or less. Now that would be a fraction because 2 out of 4 sections, 1/4 and 1/4 is 2/4. But of course, we always want to simplify. If we reduce that by 2, we get the fraction of 1/2. So yes, it says fraction, but don't let that freak you out. When you get a question like this, notice that each part of our graph is a section. So there's 4 total sections, and you would just need to see how many of those sections applies to your question. In this case, 2 sections did, so 2 out of 4 sections, which is 1/2. All right, it is your guys' turn to try this. This is one that I really enjoy. I love how it relates us to the real world. It helps us get better with working with graphs. So make sure that you take your time, read it carefully, don't rush through this. I believe that you can do it and rock this assignment out. Of course, if you have any questions, check out the IXL tutorial that's at the very top once you select your skill. Or of course, you can email your teachers for help or come to a help session. Bye.